Figure 16.6, new throwing bad underscore alloc on failure. Now, in the previous examples, we've been mainly focused on mechanical processing to indicate how to handle exceptions, how to throw exceptions, etc. In this example, we're going to look at a real-world potential problem, which is running out of dynamic memory when we try to allocate memory with new. Now, it turns out that the new operator can throw what is called a bad underscore alloc exception, which is defined in the new header file that you see here included at line 9. And basically what we're going to do in this program is, again, mechanical, but demonstrating what the potential problems are when you dynamically allocate memory. And to force our system to run out of memory, what we're doing is, in a loop, we're going to be allocating a very large number of double values over and over and over again in an array. So we've got 50 million doubles being allocated every time line 22 is executed. And rather than running this program live for you, I ran it before I started this video, and you saw that on my particular system it was able to allocate 50 million new doubles 4 times before I ran out of memory, and an exception happened indicating that I got a bad allocation, meaning that I was unable to allocate dynamic memory for the purpose of the continuing in the for loop. And of course here you see that it only iterated 4 times, even though I set up the loop to go 50 times. And of course another issue is the number of times that it will execute for you is completely dependent on how much memory you have, how much virtual memory you have, etc. In my case, it was able to get to the point of allocating the array 4 times before it failed on the 5th attempt to allocate that many double values in an array. So what we've done here is declared a pointer array of double pointers with 50 elements. Inside of the try block here, we are looping 50 times, trying to allocate an awful lot of double values at once in line 22. Every time it successfully allocates that much memory, we display a line of text showing you that the element pointer sub I points to 50 million new doubles. And as soon as it fails, or if it fails, the line 22 throws a bad alloc exception, which we then catch at line 28. And here at line 28, we refer to that bad alloc exception as a memory allocation exception. That's the name of the variable. And we use that as part of our error message to access the error message string stored in that object. And as you saw, when we caught the exception, we printed out exception occurred. Bad allocation is what the exception's what member function is actually returning to us in this example. Once we caught the exception, then at line 32 we reach the end of the catch handler. Technically the exception is considered to have been handled, and we now can move on in main. And what we would normally do in the case of a bad allocation is see if there was a way to free up some memory so that we could then go back and reattempt to allocate that memory again. And the idea here is that by throwing a bad alloc exception, we have an opportunity to now catch that problem at runtime and deal with it, or at least shut down the program in a nice manner. Whereas if the program were to simply run out of memory without giving us any warnings, any exceptions, then normally what would have happened in older systems is that the program simply would have failed without any useful information for the programmer or for the user, and separately without an opportunity to shut down the program in a nice manner. So here we've shown you that new throws bad alloc when it's unable to allocate memory, and anytime you're using the new operator, you should consider wrapping that code inside of a try block and following it with a catch that catches bad alloc exceptions, and then decide how you want to deal with those in your programs.